a Portland Community College mathematics telecourse. A course in arithmetic review, produced at Portland Community College. We have finished our first review on whole numbers and their relationships, and we begin a second unit on primes and multiples. Because some of the ideas in this next unit of study are quite new, one might be tempted to think of them as, well, strange, and resist some very important ideas. Ideas which will later help you to be able to do quite easily problems like this, finding the lowest common denominator of these three messy fractions. Most people, by the way, can't do this. If you follow through on this next unit, 3 or 4 lessons, very carefully, you'll find that this is really rather routine. This next unit will also consist of ideas which will help those of you who will go on to more advanced math. So be very attentive to these new ideas. The first concept we want to develop is the idea, simple idea, of a multiple. And we'll be asking you such questions as, is 282 a multiple of 6? Now, let's ask this question. Is 282 divisible by 6? Well, let's just see if we can divide 6 into it. The answer is yes. Now, the answer itself is not relevant to this question. The question was simply, would this divide in evenly, or would I have a remainder? If 6 divides into a number evenly with no remainder, then we say that that number is a multiple of 6. How about this question? Is 38 a multiple of 6? Well, is 38 divisible evenly by 6? And the answer is no. Just that simple. That leads us into a general definition of multiple. Any whole number which is evenly divisible by a given number, here called n, is said to be a multiple of n, except 0. We'll exclude that. Let's say you were given this assignment. Find all the multiples of 8. Well, that's the same thing as saying, what are all the numbers that 8 will divide into evenly? Well, 8 will go into 8 once. 8 will go into 16. So 16 is a multiple. 8 will go into 24. But there's an easier way of looking at this. Let's just list the counting numbers. 1, 2, 3, 4, 5, 6, and so on forever. Now notice this first multiple of 8 is simply 1 times 8. 2 times 8 gives me the next. 3 times 8 gave me 24, and so on. 4 times 8 is 32. 5 times 8 is 40. 6 times 8 is 48. So if we're trying to find the multiples of 8, all we have to do is take all the counting numbers and one by one multiply it by 8. And what we get is a string of all the numbers that 8 will divide back into. Well, since the counting numbers go on forever, the list of all the multiples of 8 is an impossible list. It goes on forever. So, point of fact, the list of all the multiples of any given number is endless. So you see, the point of this lesson is very simple: to develop a very strong, clean feel for the use of the word multiple. So if we wished, in this case, to have the first 5 multiples of 12, then we simply list the first 5 counting numbers and multiply each one of them times 12. 1 times 12 is 12, 24, 36, 48, 60, and we have the first 5 multiples of 12. And of course this list goes on forever. But these are the first 5. A simple idea, a very simple idea, but very, very important. Now, do you realize that this is a true statement? All even numbers are multiples of 2. That is, 2 will divide into every one of them. That's what we mean by an even number. So you see, this lesson is primarily about language and the use of one word in this math language, multiple. Let's look at this problem. 9 divides into 108 12 times. 9 goes into 108 evenly. Therefore, we can say about 9 and 108 that 108 is a multiple of 9. That is, it's divisible by 9. But that's just one way of saying a fact that can be said several other ways. If we had said 9 is a factor of 108, that means the same thing. But now we're emphasizing this first. This divides in evenly. It makes it a factor. But we could have also said 9 divides 108 evenly. And we could have even said 108 is divisible by 9. These are 4 ways of saying the same thing. It's just a matter of language. Here we're concentrating on one particular aspect of this language. But again, going back to what many students say at the beginning of many math courses. They will say, I cannot understand the teacher, or I cannot understand the book. Invariably, what they're really saying is this: my language is not up to that person. My language. After all, if I cannot speak or understand German, I cannot understand somebody else, no matter how simple they are saying it in German. In reality, most statements in mathematics are quite simple if, and that's a big, important if the listener is equipped with the right language. That's what this course seeks to develop, along with the review. The two, the review and the language, simply belong together. You might ask, why can't scientists and mathematicians speak in an everyday street language? The fact of the matter is, the kind of things they need to say later in your math career cannot easily be reduced to street language. It needs a technical language. Therefore, this lesson simply seeks to familiarize you with the technical meaning of one word, multiple. We will use that concept along with 3 or 4 others to explain some fairly complicated processes, unless you know those words. Then they become fairly simple. And we do this by asking some rather simple questions or asking you to do certain things. For instance, here, list the first 3 multiples of 75. If one has to ask the question, how do I do this? Then this should tell you that you don't yet know what we mean by the word multiples. So it's not a matter of how to in this case, it's a matter of what do we mean by this word. And multiples means that we want to take the counting numbers, in this case the first 3, and multiply each one times 75. So 1 times 75, of course, is 75. 2 times 75 is 150. 3 times 75 is 225. So these we call the first 3 multiples of 75. Now notice the number we want to find the multiple of, 75 in this case, is always the first multiples. Now you can take 1 times it, 2 times it, 3 times it, or you can take 75 plus 75 to get the next one, plus another 75 to get the next one, plus another 75 to get the next one, which is the fourth multiple. Now notice in this case, if I took the fourth multiple of 75, which is 300, and divided that fourth multiple, 300, by the number I'm finding the multiples of, it comes out to be that. And naturally, if 4 times 75 is this, then 75 into this must be 4. But realizing that very simple relationship will be expressed in your understanding of such a question as this. The question is 138 a multiple of 23. That question can be restated in the form, is 138 evenly divisible by 23? Or we could have said, will 23 divide into 138? Or we could have said, is 23 a factor of 128? Now at this point, it's easy to see that a student can become somewhat perturbed and think just words, 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 words. But you must realize, yes, that's exactly it. And that's what we're trying to stress here, is to begin to develop a vocabulary so you can state an idea from several different points of view using different words without getting lost in the meaning. So in this case, to ask, is 138 a multiple of 23, which is where the focus of our vocabulary building is now, is to ask, if I took 138, could I divide it by 23 and get 0 remainder? See, that's yet a fifth way of saying this. And it looks like it will go in 6 times. It will. So the fact that I get a 0 remainder is what tells me the answer to this question is yes. In fact, 138 is the 6th multiple of 23. That is, if I were to start with 23, which is my first multiple, then 2 times 23 would give me 46, so 46 is the second multiple. Then 3 times 23 would be 69, or the third multiple of 23. Then 4 times 23 would be 92, so 92 is a fourth multiple. 5 times 23, 15, carry the 1, 11. So 115 is a fifth multiple, and we're claiming that the 6th multiple of 23 is 138. So we can take 6 times 23, or simply add 23 more. And of course, if we add this, we do indeed get 138. So see, over and over, we're not so much telling you how to do something. These are all things hopefully you know already. We're playing with words until you become comfortable with sliding from one set of words to another. Until soon, using the vocabulary, we will be able to tell you how to do this very, very simply. A matter which you probably have not been told in all of your education up to now. Not because it's complicated, but because you have yet to build your vocabulary so that we can use those technical words to tell you in 1, 2, 3, 4 fashion exactly what things to do to find that one number that all 3 of these can divide into, which is a great large number. But we will indeed end this chapter in just 3 or 4 lessons by being able to tell you how to do this, and it will be quite simple at that time if we keep working on this vocabulary. So while doing these lessons of learning new vocabulary, let's, as a part of each of these lessons, constantly review a bit of our past vocabulary so we can tie all of that together in the near future. Some simple ones to get warmed up. Find the sum of anything. Remember, the sum is simply a vocabulary word which indicates the results of having added. Added what? Well, in this case, these 5 numbers. So this key word is telling us to do this. And in doing that, can you see we also get some practice in adding. See if I can do this quickly and see if you can follow me. 8, 17, 23, 30. Carry the 3. 8, 16, 20. Carry the 2. 3. 300. Now I went through that rather rapidly, so let's see if it checks on a calculator. So 53 added 2, 85 added 2, 9 added 2, 106 added 2, 47 equals 300. So do practice your long hand arithmetic. At the same time, we encourage you to begin to become comfortable with the calculator, to check your longhand practice, but most importantly, to realize in this case, the word sum means the results of having added. Always, as you're reading, be on the lookout for that key word. Difference means the results of having subtracted. And always the first number that's given is written first, and the second number is written secondly. And if you're going to do it in a calculator, this is as easy a way to write it as there is. If you're going to do it by hand, the vertical form is perhaps better. So 5 from 10 is 5, 9 from 9 is 0, 8 from 9 is 1, 4 from 7 is 3. Did you follow me? So again, by hand, then check by calculator. 8000 minus 4895 is 3105. It checks. But the key word here is difference, which means the results of having subtracted. And the first number given is the first one, or the top one. Second number given is the second one, or the bottom one. Then subtract in the exact order that is given to you when you use the word difference. Other words might give us a different order to these listings. Another one. What's the key word here? And of course it's the word product, isn't it? The product meaning the results of having multiplied. In this case, 13 and 19. So however you're going to do it, the key to this problem is not getting an answer. See, we learned how to do this in elementary school and reviewed it in the last chapter. What we're trying to do now is tie down vocabulary. And of course, if you know what the vocabulary is saying, you know exactly what to do. So on these types of problems is not the answer that's important. In reading the statement, did you know what to do? If you did, then that, and that alone, is the lesson. Of course, it does give us some practice, which we can always use. Then along the way, we begin to give you more complicated, what you and I probably used to call story problems, not to see if you know how to do this, but to see, are you developing a good enough vocabulary so that in reading this you will know what they're talking about, and hence you will know what to do. So in this case, let's see if we can begin to get a feel for what's being said here and what's being asked for. I have a storage tank containing 2,090 gallons of gasoline. Now sometimes it will help you if you draw a little bit of a sketch of what's happening. Okay, so in this case I've got 2,090 gallons in a large storage tank. If 12 gallons are pumped into each of 35 cars, so we've got 35 cars here, and each of them are going to have every single day 12 gallons in each. Then how many days will this large storage tank last this supplier? Well, first, this right here stands for a day, doesn't it? So we have 12 gallons being filled in 35 times. So each day I will use 35 times 12 gallons of gas in these cars. Now, are you beginning to see what's happening here? And see that I'm using a diagram in this case to sort of feel my way through what they're saying if I don't see it in the words alone. Of course, with practice, you will see it in the words alone. So, multiplying these two, we get 420 gallons, but for what? Well, 420 gallons of gas per day in those 35 cars. So now we're asking how many of these are in here. Here's one 420, here's another 420, etc. So we're asking how many times will 420 go into this? Here's once, here's twice. So basically we're asking at this point, in 2090, how many times will 420 go into it? And it looks like about 4, doesn't it? See, 0, 4 2s is 8, 4 4s is 16. Subtracting, we have 0, 1, 4. So if this is how many are going in each day, this will go in 4 times, leaving me, when I'm all done, 410 gallons. So the answer to my question, how many full days will the tank last? 4 days. And of course you can see very, very easily that this is the type of problem that a service station owner has to be aware of, or any grocery operator. They must know ahead of time when things are going to run out, so they can project ahead and order ahead of time. You can't wait until you're out and then order it. Business would go broke trying to do that. So what a businessman must do is anticipate what's happening, anticipate what he's had, and be able to answer questions like this. So this type problem is being done a multitude of times every single day in dozens of places in your very neighborhood. So the point we're making is this. In math, a good vocabulary is a must. It's not nice, it is a must. It is impossible without it. So we will constantly nudge you on vocabulary. And in this particular lesson, our key vocabulary word, along with all of these we've just reviewed, is, do you know what is meant by the word the multiple of a given number? If so, you could answer this question very nicely. What is a sixth multiple of 9? Well, it's simply 6 times 9, which is 54. Now, what do we mean by multiple? Well, it means if I started with 9 and counted by 9s, so 9 and 9 is 18, 18 and 9 is 27, 27 and 9 is 36, 36 and 9 is 54, that if I counted by 9s, that the sixth number I would get to by thus counting by nines is 54. So we're saying more than the fact that 9 will divide into 54 to be a multiple of 9. To say that it's a sixth multiple means that, in fact, it is the sixth number in my list that I could divide evenly by 9. And it's that kind of sequencing that this word multiple allows us to focus in on by our communications. So if I were to ask to list the first 4 multiples of any number without even knowing what this number is, you know immediately you're going to take 1 times it, 2 times it, 3 times it, and 4 times it. So if somebody were to say, I want the first 4 multiples of, say, 20, you're going to take 1 times 20, which gives me 20, 2 times 20, which is 40, 3 times 20, which is 60, 4 times 20, which is 80. So these are my first 4 multiples of 20, and of course 20 itself is a first. And furthermore, and this is important to our future lessons, this list goes on forever. It's an infinite set of numbers. And of course, a good teacher can check your understanding of a vocabulary by rephrasing questions using that word many, many, many ways to see if you can hang with the meaning of this. So what is the sum of the first 3 multiples of 14? Well, the first 3 multiples would be 1 times 14 is 14, 2 times 14 is 28, 3 times 14 is 42, and this says what is the sum of those first 3 multiples, and sum means the results of having added, and of course that sum is 84. Now please note, as you pursue this and future courses, the answer to this arithmetic is somewhat irrelevant. It's merely a vehicle to see if you, the student, really caught the vocabulary. If you need to ask somebody else, how do I do this problem? Realize, being honest, you have missed the whole meat of the lesson. Because if the lesson is, do you know what this vocabulary is? If you do, you will know what to do. Problems will change all the time, but the vocabulary, that's with us for the rest of our math career. This is your host, Bob Fennell.